Good morning, everybody. My name is Korra Kiran, and my branch is mechanical engineering. Today, my subject is machining process and metrology. Here we can see my topic is AI assisted control of residual stresses in machining operation. And here my topic introduction is introduction to residual stresses in machining. Residual stresses are stresses that remain in a material after the completion of a manufacturing process. They can significantly influence the mechanical performance and longevity of a machined component. Managing these stresses is critical for enhanced component reliable and performance. Challenges posed by residual stresses. Uncontrolled residual stresses can lead to destruction, cracking, and pyramid failure of parts. Traditional machining process often induce tension residual stresses that are detrimental. Effective control methods are required to mitigate adverse effect and improve part quality. Here, overview of AI-assisted control techniques. Aluminum AL. Aluminum is used for various advanced machining and surface treatment process. AI-assisted methods involve applying aluminum-based material or process to influence residual stresses. These techniques aim to modify profiles to enhance mechanical properties and stability. Here, fundamental of residual stresses formation in machining. Uh, Residual stresses originate from thermal gradients, plastic deformation, and phase transformation during machining. Cutting parameters such as tool speed, feed rate, and cooling significance impact stresses development. Understanding this mechanism is essential for designing effective control strategies. Role of aluminum in residual stresses management. Here, aluminum's unique physical and chemical property make it suitable for surface modification. That was the role of the aluminum in residual stress management. At the same time, aluminum-based coating or treatment can induce compressive stresses on the surface. At the same time, this induced stresses help counteract tensile stresses and improve fatigue life. AI-assisted surface treatment and coating. Techniques include aluminum alloy coating, thermal spraying, and vapor deposition. Surface treatment modify the stress distribution, reducing the risk of crack initialization. At the same time, proper application enhance surface hardness and residual stress profiles. And laser-assisted aluminum surface modification. Laser techniques enable precise application of aluminum coatings with controlled parameters. Laser processing create localized residual stress modifications for targeted improvements. At the same time, this method provides high accuracy and minimal thermal disruption. Now, ultrasonic and vibrator AI assisted machining. Ultrasonic vibration combined with aluminum tools can influence the residual stress distribution. This method promote finite surface finishes and stress relaxation, and they also reduce cutting force and improve overall machining efficiency. Now, benefits of AI assisted controlled method. Through the year, there is a pie chart like machining operation and elastic or plastic deformation, non-uniform phase transformation, and residential. This was one of the brief explanation of this benefit of this. Oh, sorry. And now we can see here, enhance surface integrate and reduce internal stresses lead to longer component life and improve dimensional stability, minimize post machining finishing requirement. This method contribute to sustainable manufacturing by reduce waste and rework. Challenges in implementing AI assisted techniques. Precise control of process parameters is necessary for consistent result. Cost and equipment complexity may limit wider speed adoption. Further research is needed to optimize techniques for different material and applications. Here the case study and experimental result. Student demonstrate a significant reduction in residual stresses after AI-based treatment. Improve Fatigue resistor and corrosion performance are observed in treated samples. Data supports the effectiveness of AI assisted method in industrial application. Future strength and innovations. Integration of AI and machine learning of real-time process control in emerging. Development of hybrid techniques combining AI assisted methods with other stress controlled strategies. Advance aim for a more sustainable cost efficiency and adaptable solutions. Here, practical recommendation for industries. Tailor AI assisted process to specified material and machining conditions. Another thing is incorporate residual stress manufacture measuring techniques for process validation. Invest in training and advanced equipment to maximum benefits. Here the conclusion. Once we can see what we are learning this topic with the head topics. Here the topic is AI means aluminum assisted control for residual stress in machining process. Here introduction means nothing but it is the stress that remain in material after the completion of the manufacturing process, and it have the mechanical performance mainly component. And the challenges here is nothing but it have the cracking and disruption at the same time perimeter failure that was one, and the traditional machining process also, which is the tensile stresses. Overview of aluminum assisted control technique here is nothing but it can various application it have at the same time. It may called as the external load or the applied load. Through that we can say that the profile of the measuring property and their stability. And fundamental of this is nothing but it has the thermal gradients and the plastic deformation, and one more thing is phase transformation. These are the what we call phase changes. At the same time we also call it as like residual stress in metal, how they are there, like their tension or the compressor of the cutting. We know that the cutting parameters are three, that is speed and feed and rate. That was the one of the thing we can see. And the role of the aluminum is actually aluminum is both chemical and physical property. It is a unique property also. Through that we can use this was in that our experiment. At the same time, it have the individual compressive stresses on the surface, especially for the coding purpose. And this was a coding here. We can see the flow chart also, how they are machining operations. At the same time, plastic and elastic deformation, unique phase transformation. The last residual stress in the workpiece. In the laser data sheet, here one of the main thing we need to notice that was is that in this there is a high accuracy of this aluminum surface modification because of the application of coding. That was the thing we can need to remember. And ultrasonic and vibratory AI in machining is nothing but in there is aluminum tools can influence the distribution, and in that vibratory means nothing but they improve the machining efficiency by the cutting the force. That was one of the thing also we need to learn. And the benefit is nothing but main benefit is it is the longer component life. That was the main benefit. And also at the same time it have the post machining finishing the equipment also. And the challenges in implementing AI assistant techniques here, one of the challenge we can see that was maybe limit of the cost and equipment was the that one thing of the complexity of the technique. The case studies and experimental result also mainly like tensile residual stresses after AI treatment. That was one thing we need to notice. Future trends on innovation. Future trends is nothing but it have the machine learning of real-time process, control its emergency. That was the one of the future. And other thing is that was innovation means we can more sustainable and cost effective and adaptable solutions also we can learn. Now, practical recommendation for industries. What are the practical recommendation for the industries to go and view, or we need to notice each and everything in the industries? First of all, first main thing that we need to remember is specific material and machining condition. The condition of the material and what are the things we can measurable the techniques of the process, and it has a validation also. We need to see in the industries. And conclusion is mainly here the AI assisted control for control of residual stresses offer promising solution for machining improvement. That was one of the conclusion. Another thing is enhance part performance, durability, and manufacturing efficiency. Manufacturing efficiency. This was the main thing we need to understand. That based on the application, we can use this performance, and the performance mainly durability and manufacturing efficiency. And ongoing research and technological advancement will further expand this techniques capability. It has the capability in further also. It may become, and here we can see the reference and acknowledgement at the last. Thank you.